The qualitative analysis. For the qualitative analysis, 10 marks maximum will be given in the final chemistry practicals. This qualitative analysis is nothing but an identification of cation and anion present in the given salt. It consists of 3 parts. First one is physical examination of the salt, detection of anion and detection of cation and the report. First let us see the physical examination. In the physical examination of the salt, the first point is we need to mention the physical state. Here physical state means only solid substances will be given to us. So take the given salt between the 2 fingers, then just rub it. If ever you feel it just like a talcum powder, then it is amorphous. If ever you feel it is just like a salt, a common salt, then it is a crystalline. Almost all are crystalline. So in the physical state, we need to mention whether the given salt is a crystalline or amorphous. Then next is the color. Now generally the 3 salts which are in the intermediate practical examination syllabus are colored ones. Now the first one is cupric salts. Cupric salts are blue colored like this, and ferrous salts are light green colored. Then manganese salts are this pale pink colored. And apart from these 3, all the remaining are white colored salts. So if any one of these salt comes, then you need to mention that color against to that color property in the physical examination. Suppose no color, you can write just no color. Then after that, then the next part is this solubility. Take the small quantity of the given salt to you in a test tube and add water. All the salts which are in the syllabus are water soluble. So simply we can say that salt is soluble in the water. Then after action of heat. So take the small quantity of the test tube, the small quantity of the salt into the test tube, then heat it. Whatever be the change that is observed in the test tube, you just mention. Now for doing and for writing the physical state, color, and solubility, action of heat, 2 marks will be awarded to us. That is, each one of these will carry half mark. After this, then we need to go to detection of anions. Only 5 anions are in the syllabus. They are carbonate, chloride, bromide, nitrate and sulfate. So first of all, in the detection of anions, we need to do action of dilute HCl. So for that, I am taking some carbonate salt into this test tube. Then I am adding a dilute HCl like this. Now this is called a quick effervescence. Means a quick effervescence is nothing but the evolution of gas in the form of bubbles from this bottom of the container. If ever this quick effervescence is observed, we need to mention the same thing, and in that experiment part, first we need to mention what we are doing in this experiment in the form of experiment, and the second part is observation, third part is inference. In the experiment, a small quantity of the given salt is taken in a test tube and a dilute HCl is added to that. That is the experiment part. Observation. Quick effervescence is observed like this. And that we need to mention this observation. Inference. Carbonate may present. Now, suppose if quick effervescence is not observed, we need to mention the same thing there, that quick effervescence or no change is observed. Then carbonate is absent. If the carbonate is absent, we need to proceed for the identification of the remaining ions. Suppose if quick effervescence is observed, then carbonate is present. Then immediately what we need to do is a burning splinter should be exposed to the gases that are evolved from this test tube. If quick effervescence is observed, then the burning splinter will be put off. Then there also we need to mention that carbonate ion may present. In all the identifications of cations and anions, once we say that this cation may present, then immediately we need to do the confirmatory test for that. In the confirmatory test, we need to take the salt solution and add barium chloride to that. And we get a white, beautiful white precipitate. Then we need to mention that a white precipitate is formed. Then add dilute HCl to that. Then that precipitate will be dissolved. So in the inference part, carbonate ion is confirmed. If ever the carbonate salt is given to you, your identification of anion is completed. And for the identification of anion, 4 marks will be awarded. If ever your salt has carbonate, for doing action of dilute HCl test, 1 mark will be given, and for burning splinter test, 1 more mark, and in the confirmatory test, action of barium chloride solution, 1 mark, and for finding out its solubility, 1 more mark. So 4 marks, and for the physical examination of the salt, 2 marks. 6 marks are over. Suppose if your salt does not contain, that means quick effervescence is not observed, then don't do burning splinter test and this action of barium chloride solution. The quick effervescence is not observed with dilute HCl, then carbonate is absent. Then we need to go for the other anions. The other anions may be chloride, bromide, nitrate, and sulfate. So first let us do that action of concentrated sulfuric acid. With this, chloride, bromide and nitrate will be identified. Now I have taken the given salt into the test tube, that is, this is a chloride salt. Now I am adding a concentrated sulfuric acid. Now, then immediately you will find that some reaction is going on in the test tube. Then you can smell the gases, and if ever you get pungent smelling, colorless gases with a strong odor, then the given salt contains chloride. Suppose if the given salt is a bromide, now I have taken the bromide salt. Now I have added the same concentrated sulfuric acid. Now I got that reddish brown vapors. Wonderful, you can observe in it. So reddish brown vapors are evolved. Immediately the moment we add concentrated sulfuric acid, we will get reddish brown vapors. If ever you observe this kind of change, then bromide may present. If ever neither colorless gases with strong odor nor reddish brown vapors are evolved, then we need to mention no change is observed. Chloride and bromide are absent. Then heat the test tube. After heating, if ever we get reddish brown vapors, then nitrate may present. Now, if ever we get either colorless gases with strong odor or reddish brown vapors, then based on that change we need to mention that either chloride may present or bromide may present. If no change is observed, both chloride and bromide are absent. No change observed upon heating the test tube containing the salt and the concentrated sulfuric acid, then nitrate ion is absent. So already we said that carbonate is absent, chloride is absent, bromide is absent, and now nitrate is absent. And the only anion that may present is sulfate. We need to proceed further for that. If ever some change is observed on adding concentrated sulfuric acid, like colorless gases with strong odor or reddish brown vapors, then either chloride or bromide may present. Then we need to do one more test for that, that is the action of manganese dioxide and concentrated sulfuric acid. So for that I am taking this chloride salt, and to this I am adding concentrated sulfuric acid. After adding concentrated sulfuric acid, now I am adding manganese dioxide. Here, if ever we observe the test tube in the inner walls, then we will observe that a yellowish green gases are evolved. If yellowish green gases are evolved, then again we need to mention that chloride may present. Suppose if reddish brown vapors are evolved upon adding concentrated sulfuric acid to the salt, then we need to say that bromide may present. And again we need to do one more test for that bromide, that is action of manganese dioxide. There again I am taking a small quantity of that bromide salt into the test tube, and to this I am adding a pinch of manganese dioxide. Then I am adding a concentrated sulfuric acid. Reddish brown vapors are evolved, then bromide may present. Your salt does not give any test on adding action of concentrated sulfuric acid. Chloride, bromide are absent. Then don't do the action of manganese dioxide and concentrated sulfuric acid. If ever that salt gave reddish brown vapors after heating and after adding concentrated sulfuric acid, nitrate may present. If nitrate is present, then do action of that concentrated sulfuric acid and copper turnings. That is, take the salt into the test tube, add 1 or 2 copper turnings, then add concentrated sulfuric acid, heat it. Then reddish brown gases are evolved. Again nitrate may present. Then we need to do the confirmatory test. If ever your salt contains either chloride or bromide, upon adding concentrated sulfuric acid, you got either colorless gases or this reddish brown vapors. Then you did action of manganese dioxide and concentrated sulfuric acid. There for chloride greenish yellow and for bromide reddish brown. The confirmatory test for chloride and bromide is take the salt solution. That is, salt solution is nothing but the solution prepared by dissolving the given salt into the water. Then take that salt solution, add silver nitrate. You will be getting white precipitate if ever it is chloride. And after getting that white precipitate, add ammonium hydroxide. That precipitate will be dissolved. So chloride is confirmed. And if ever it is the bromide, you said that bromide may present. Take the salt solution, add silver nitrate. Then pale yellow precipitate will be formed. Then add ammonium hydroxide to that. Precipitate is partially soluble. Then bromide is confirmed. That is, if your salt contains either chloride or bromide, the procedure part must contain action of concentrated sulfuric acid, number 1. Number 2, action of concentrated sulfuric acid and manganese dioxide, and the next one is confirmatory test, that is action of silver nitrate, and that is solubility test. If ever your salt contains nitrate, and for the confirmatory test of nitrate it is a brown ring test. It is one of the beautiful tests in the intermediate chemistry practicals. So for that brown ring test, I am taking the salt solution, then I am adding freshly prepared ferrous sulfate. That is, the ferrous sulfate is readily available in the laboratory. So dissolve some ferrous sulfate into the water, and that solution will be added to the given salt solution. Then keep the test tube in the slanting manner. After keeping the test tube in this slanting manner, then add concentrated sulfuric acid along the inner walls of the test tube. Now you will find a beautiful brown ring. This is the confirmatory test for nitrate. So brown ring will be formed at the junction of two layers. Two layers is nothing but one is the salt solution, another is the added ferrous sulfate, and between these two layers this brown ring will be formed. So there we need to mention that brown ring is formed at the junction of two layers, and nitrate ion is confirmed. That is, if ever your salt gives some reaction with the action of concentrated sulfuric acid, then it may be chloride, bromide or nitrate. Suppose no change is observed on adding concentrated sulfuric acid, then no change is observed. Chloride, bromide are absent. Then the above test tube is heated. Again no change is observed. Nitrate is absent. Then you need to proceed for the action of barium chloride solution for sulfate identification. For that we need to do action of barium chloride test. So now I am taking a sulfate salt solution, and to this I am adding barium chloride. Now a white precipitate is formed. If ever white precipitate is formed, then sulfate ion may present. Then immediately we need to do the confirmatory test for this. So for that, to the same precipitate I am adding concentrated HCl. Now precipitate does not dissolve in concentrated HCl. If the precipitate is insoluble in concentrated HCl, then sulfate ion is confirmed. That means your anion part is completed. So for anion 4 marks will be awarded, and for physical examination 2 marks will be awarded. So overall 6 marks part of qualitative analysis is completed. And the most important is, if your salt contains sulfate, it must include number 1, action of dilute HCl, no change is observed, carbonate is absent. Action of concentrated sulfuric acid, no change is observed, chloride, bromide are absent. The above test tube is heated, no change is observed, nitrate is absent. Then action of this barium chloride solution. If ever you got sulfate, but you have not written action of dilute HCl and action of concentrated sulfuric acid, then you will be losing 2 marks. So even for writing the negative test also, marks will be given. So we must follow the procedure in toto in the laboratory. So chloride, bromide, nitrate, sulfate, and initially the carbonate. So these are the only anions present in our syllabus. In the intermediate chemistry practical syllabus of qualitative analysis, 11 cations are there. These 11 cations are grouped into 6 groups. Identification of the proper group is very important, and after that confirmatory test. In all the cations detection, first of all what we need to do is take the given quantity, keep the salt into a test tube and add water, prepare a full test tube of salt solution, keep it aside. Then take small quantity of that salt solution into a test tube. Then let us do identification of first group cations. That is lead. So in the case of this first group cations test, I am taking the salt solution and into this I am adding dilute HCl. Now the precipitate is formed. If the precipitate is formed in the identification of first group cations, then first group cations may present, that is lead may present. Then immediately we need to do the confirmatory test for this. So in the case of confirmatory test, I am taking the given salt solution and into this I am adding potassium chromate. Now a yellow color precipitate is formed. If yellow color precipitate is formed, then lead ion is confirmed. If ever lead is present in the given salt, then we should not proceed further for the remaining cations, because we got the cation that is present in the given salt. In the identification of the first group cations, if no precipitate is formed, then first group cations are absent. Then we need to proceed for the identification of second group cations. Now to the same salt solution, that is salt solution and dilute HCl, the second group reagent, that is hydrogen sulfide, is to be added. Now upon adding this hydrogen sulfide, here black color precipitate is formed. If the black precipitate is formed, then second group cation, that is cupric ion, may present. If ever we get this black color precipitate, then immediately we need to do the confirmatory test for cupric ions. That is, again I am taking the salt solution. To this I am adding this ammonium hydroxide. Now bluish color precipitate is formed. If the bluish color precipitate is formed, then cupric ion is confirmed. If ever in the second group also no precipitate is formed, then we need to proceed for the third group